welcome to mold number 7 of the 100 mold project. This is a votive candle and has the same shape pattern as the Flynn, which was 2 of 100. This is also the first votive candle that we have made, and certainly the first I've machined. Because of the size of the hole, it's too small to use any of my current lathe tools, but it's also a pretty large hole, and I know it's going to present some challenges on the mill. My machining strategy on this shape is to cut a roughing draft on the lathe and then move it to the mill for finishing. The idea is to move it to the mill so that I can cut the inner and the chuck using a 3-axis operation. After that, it'll move to the 4th axis on the mill to cut the outer profile shape. I did my first 4th axis profile in detail that was the same as this one, so I'm not going to go back over that in this video. I will link the video for you in the top corner right now though. I use the lathe because it gets me a perfectly round blank to start with on the mill so that I have something to reference off of that's a perfect shape. Any stock we get is not actually perfectly round when we get it. And so I'm going to do it on the lathe so that when I put it on the mill on the 4th axis especially, it's perfectly round to reference off of. First step on the lathe is to reference Z. This is similar to what you might do on a 3D printer. You're telling the machine basically where the stock starts. A lot of videos might recommend paper like they do in 3D printing, but with the coolant that gets wet, I have found that I've gotten some of this metal shim sheets and I like to use those. Now to the mill. The first step here is to use an inductive probe to tell the machine where the stock is. That's why it's so important for the shape to be perfectly round, so I can make sure when I cut out the center it matches what is referenced when I move it again to the 4th axis as the last step. Some tools I hardly use, and while everything should be referenced correctly in my tool trays, on the machine, I always do a sanity check for tools that I hardly ever pick up, and so that's what I'm doing here. This is the long end mill I'm going to use to finish the inside of the votive candle. So the first tool path on the mill is going to be to an adaptive tool path to clear out the inside. This one I've done many times before, so I'm not too nervous about this. We'll go ahead and kind of speed past this to get to the good stuff. So this is only my second time actually using this end mill. The first time I used it, I actually broke it and crashed it, so I'm pretty nervous at this point. First is a ramping move to get to the bottom of the jar. I actually have realized at this point that I don't need to do this because it's already been cleared. For whatever reason, the CAM programming thinks that it needs to do this. This is probably just a novice in me not knowing how to make it do what I want it to do. And if you look here, you can see what I'm talking about. It's this red spiral the tool is doing to get to the bottom of the jar. So one thing that's really important in machining is the sounds that the tools are making as they're cutting things. And as you'll see in a second, I instantly know something is wrong by the sound, so I won't talk so you can hear it. And the machine just stopped, so it's back to the drawing board. I actually ended up going into the programming to try to figure out what's wrong with it. The finish on this is actually not that bad, but when I went in the program, I realized that for whatever reason, what should have been 0.01 as material to remove, I made a error and put 0.1. So it was just cutting more than the tool can. As I'm going back into the CAM programming to fix this, I also went ahead and changed the entry method from ramp to plunge, and that fixed the issue from before where it took forever to get to the bottom of the jar. So this is my second attempt, and if you listen again, you can hear it just doesn't sound right to me. So I go back to the drawing board, and at this point I change from climb milling to conventional milling to see if that makes any difference, and it does not. Because my toolpath still doesn't sound right, I then go to kind of a cheat sheet I use called Proven Cut, and it has a bunch of recipes. So I go here from sanity check sometimes, and look here, there's nothing that seems to replicate what I'm trying to do. So I just kind of decide that the first pass that I had done that stopped the machine actually felt pretty good. So I decide to stick with the climb milling. And so I just go with it, and my strategy is to take just really light passes in a climb strategy and see if that does the job. So this is the last time, hopefully I have to do this, but if you watch this video, something really terrible happens. The workpiece has fallen off the work holding device I have going there. I, at this point, kind of think about it, and I realize that first time the machine stopped actually loosened the screws, and some of the sounds I was actually hearing was the vibrating of the screws, or the vibrating of the workpiece against the tool. So I go back and start anew and get a new piece of stock and go back to the lathe, and then we will go back to the mill. So here's my last pass at the inside. In the end, I don't love this. It really doesn't have the best finish, and I end up hand sanding it a little after the fact because I can still feel some pretty deep machining marks. I am determined, maybe in another mold in this project, to figure out how to do this. And here it is on the last step on the fourth axis in the mill. This ends up taking a long time. I chose to use a 1/8 ball nose end mill and a 0.2 degree step, and it just took almost 2 hours. I didn't even look at the machining time before I started this, but once I was in it, I was on my second try of it, so I just went with it. So something to remember for next time. And the mother mold is done. While I don't love the inside of it, the outside finish is pretty spot on, and I'm pretty excited about this one. So let's go pour some silicone.